In this video, we will discuss the structural analysis and design of two-story reinforced concrete residential building. Okay, this is the course, the online course in the ENT tutorials, and our topic is number one. I think I don't need to include this one. Then I will go to structure geometry design criteria. Okay, so we'll go to number 2. Okay, for the number 2, okay, I am on this PowerPoint file. Okay, so this is the FrameCE structural engineering software, and this is our structural 3D. This is analytical model or mathematical model, and after I will just show the 3-dimension. Okay, and this is our structure. Then this is the column layout. So we have here grid line 1, 2, 3 ABC with 7 meters, and 8 meters. Okay, so we have a column. So this column is under analysis, or this is the assumption column. Okay, let's say 400 by 400. Next is the framing plan. So this is, I will just show this one. This geometry or these framing plans are already in the for construction drawings. Okay, this is the foundation plan, and then this is the ground floor framing plan. So technically this is slab on grade. Okay, then we have here second floor framing plan and roof floor framing plan. Then we have the building section. Say we have from top of foundation, we have 2 meters to ground floor, and we have 4 meter. I think this is 3.6. So this is 3.6 meters. Next is we have here 3.2 meters, and we have 1.2 parapet wall. Okay, next is this is the slab reinforcement plan. So I just put the slab reinforcement here, diameter 12 at 200, both ways. Also, I think this is top and bottom. Okay, so this is the design criteria. So the weight, the dead loads, unit weight of concrete and steel, so that is 25 and 78.5. Then the rebar design strength to 75 for 10 mm and 12 mm, and larger is grade 60 or 414 megapascal. Then for the concrete, we have 3000 for footing, beams, and slabs, and 4000 for columns. Then we have here superimposed dead loads. So for the ground floor, we don't have the superimposed dead load because the slab on grade will take care for the loadings at the ground floor. Okay, and at second floor we have 50 mm floor finish, and let's say we have suspended ceiling and interior walls partitions. So just derive it and 3 kPa. So total is 4.55, and for the roof we have roof topping. This is 1.875, and ceiling 0.4 and 2.3 for the roof deck. SDL total. Okay, so we also have line loads here. So we have from the perimeter of the ground floor and second floor, we have here this value. Okay, so you can go to this table, and for the roof deck we have this value, and also I think it's not included. Okay, next is for the live load we have residential, and this is reducible live 1.9, and also for the roof deck this is accessible area. This is also reducible live load. And for the wind, this is the values, and for the earthquake, this is the value. Occupancy category, since this is residential, we are standard occupancy, and the importance factor value is 1.0, and the seismic zone, let's say this is zone 4, and seismic source type B, soil profile type is S sub C, and the distance to source 10 km, and this value of their source factor and seismic coefficient response factor, this is CA 0.4 of N8 and 0.56 on NB. So this is the references you can choose, or you can get it from these tables. Okay, so this is the zone 4. For this exercise, we use this data, or our location technically is here. Okay, and structure details, so configuration requirements, so this is regular structure, moment resting frame, static force procedure, and I think we can utilize method A, and the reduction of pressure is 8.5, and our soil bearing capacity is 250. Let's say this is, for example, from the soil investigation report. Okay, and for the modeling requirements, we have here the crack section modifiers for elastic analysis. Factored load level exert from NSCP 2015. So this is the values. Okay, and then this is our load combinations. And now we will start the modeling. Okay, so for the design strength requirement, the nominal greater than equal to ultimate. Okay, then this is our reduction factors. So next video is the modeling using FrameCE.